Thanks for that. Just a quick note, there's some sessions which will be, or all sessions will be recorded today, but some will only be shared internally with our internal channels like Forum and the Discord server. But some conversations are going to be shared publicly. So if for those sessions you don't want your video recorded, you're welcome to switch it off. We would, of course, love to have your faces giving us feedback and love to have your expressions. So we would love it, obviously, if you have your video on. Nastasia, do you?
Yeah, I just wanted to clarify that we would only be publicly sharing the content parts. So while we're presenting and sharing the screen, these are the parts that we will publicly share. But while we have the Q&A, these parts wouldn't be shared on YouTube.
Awesome.
Publicly.
Thank you. Thanks. Yeah, so that's just setting a few hygiene things, basic things for our session today. We've got presentations from Guillem and then some Q&A, and then we take a break and then a session with Nastasia and some Q&A. And that's how we're shaping up for today. As always, we're recommending you drop your questions in the Discord channel. That just helps us because we have a very streamlined process with regards to picking up questions and answering them. So if it's all in one place, it just helps us a great deal. So the Discord channel is, I think all of you are in the Discord server, and within that server, it's the 7th session, October 26th channel. I'll drop a message in there to indicate that's the channel we're using for questions. And so we would recommend, as the sessions or the presentations are underway, please drop your questions into the Discord server so we get a sense of how the session's going and how much time to leave for Q&A. So don't hesitate with questions in the Discord server. And with that, I will quickly hand it over to Guillem, who's going to take us through the first session, and he's going to be talking to us about update chains and the round data model using playground visualizations. So over to you, Guillem. I think especially the update chains is pretty interesting, and so keep your questions flowing. Like, I think there's some real juicy bits to be discovered and chat and talk about there. Over to you, Guillem.
Yeah, the wonderful world of update chains. It's interesting when you're learning these kinds of concepts, because again and again you find things that you don't expect fully, like, okay, we are going to see some weirdness about updates and in Holochain, and then later on you can trace it back to, oh, okay, decentralized systems, distributed systems have a very different nature to centralized ones, and this is like weirdness in updates is just the downstream effect of that, and it just we were used to another thing, right? And it's interesting, like this keeps happening again and again for me, at least. Okay, so I'm going to share my screen. Desktop 1, can you see my screen?
Yes.
Cool. Okay, so topic of today is update chains. Well, before chaining them, I guess we have to talk about updating, right? So I'm going to show you basically what's an update in Holochain, how does it work, and the implications of it. And then we are going to switch over to the DevCamp application, right? So like the one that you all have already coded and everything, which is create game code, join game code, right? First, we are going to stay a bit in the abstract and talk about updates, how updating an entry really works in Holochain as a basic primitive, right? Okay, so what we already know is that in Holochain, you can create an entry, right? So I go here to Willeta, and remember, this is a DHT, 10 different agents are running the same application, and the application exposes some functions. We are going to call one function for we let us node, right? So going to create an entry here. The entry gets created, okay, published, and let's see, I'm going to switch off the agent entries because I don't care about them. And now we have a demo entry, right? This is the entry that we just created with the content that we just created. Cool. So we have here now one thing called update entry, which is like, okay, we now can update the contents of an entry, right? So let's go, like I'm clicking this demo entry. Let's go over to, oops, okay. I'm going to copy the hash of the entry, right? So the hash of the entry is in principle what identifies it. Now I'm going to say, update this entry to this new content. Okay, so let's see. Oh, didn't work. Why it didn't work is it says trying to retrieve a header with a hash of another type. If you see here, the input of update entry is not the entry hash, it's the header hash. And that's the most important thing about the updates, really. You are not updating an entry directly, you're updating the header that created it. And that's really important. So what I have to do actually to update this entry is I have to go show headers and see this is the header that created this entry, right? This is the create header. We already went over this, like we are relying on previous knowledge of previous sessions, but if you have questions around these basic building blocks, also post them, because if you don't get previous knowledge, you're not going to get the new one. So what I'm going to do is go inside the create header. And now here we have header contents, right? And the create header, the most important thing about the create header is that it has the entry hash here, which is why it's linked. And now I'm going to copy the header hash, right? So remember, there is the entry hash is one thing, there is the header hash is another thing. You can do a get with both the entry or the header hash, but when updating, you can only use the header hash. So I'm going to copy, paste, execute. Let's see. Okay, so what just happened? There is a new update header that points to a new demo entry. Let's just check. The demo entry contains the new content that we put here. And in the update header, we have the original header address, right? Which is, we put the original header address here as an input to update entry, and now we have it inside the update header. So this is basically saying to Holochain, hey, this entry that was previously created, now its header, you can update it, right? And Holochain offers you this primitive, and it's up to you a bit to how to interpret it, right? So first thing that it's not the same as the centralized system is demo entry still exists. The demo entry if I go copy its hash and then I do a get on that entry, I'm going to get back the entry, right? Even though it's updated in Holochain, the DHT is monotonic. You can only add to it, and updating an entry means adding a little bit of metadata to the previous entry and a new entry, right? So updating an entry really is create entry plus notify the previous entry that it was updated, right? This is the main idea. Okay, so then we are beginning to know how update works. What's an update chain then? okay, so imagine that I created a node here. This is a node taking up. Demo entry is a node. Demo entry 1 is a node. Demo entry 0 is the new content of the node. What if I want to update the node again? Okay, so I just have to go to the latest update header in this case and do the exact same thing as we did first time. So copy its hash, go to update entry, put the header hash here, not the entry hash, and put even newer content. Execute. Okay, the diagram could be improved a bit in its drawing, whatever, but I think you can, okay, you can see that this is a chain, right? So you have first header, it's the create one, right? You cannot update without anything to update. So first header is the create one. Then it comes a second header, which is update. Update points to the first create one. And then the second update points to the first update that points to the original create, right? So this is the update chain that we have been talking about, right? And this actually you can discover backwards and forwards, right? What do I mean by that? If you have the latest update, for example, you can go backwards because in this update header, you have the original header address, right? And you can do a get here, and you here you have the original header address which is the first create, and you can go get that. But Holochain also tells you which headers had updated the create header. So if I were to do a get details, for example, in the demo entry 1, let's see what we get. We get details for just by the way, it's a get, but get me everything related to this entry, right? So in this case, get details is returning the contents of the entry, all its headers and all the headers related to it, right? So get details is returning as the content of the entry, the header that created it, and also if you see here, the updates that updated it. Right, so this is just to explain that in this chain you can go backwards and forwards, right? If I know the hash of the first entry, I can go get details and get the hash of the update header and go get details on that and go to the next one, right? So this is important when thinking about what links you need and so on.
Just a quick question. Otis
Yep.
has a question asking, how did we get the order entry 1, entry 0, entry 2?
Right, it's random in this case. Okay. So it doesn't matter. Like it doesn't have meaning more than randomness.
Cool.
Like actually demo entry 0 should be this one because it's the first one that was created.
Yeah, I think that's what was confusing too.
Yeah. The demo entry 0 should be demo entry 1, like first, second, third, right? This is the proper ordering. Cool. Okay, so last point about the primitive, which is I'm going to refresh. A lot of people seem to get confused around this, so I'm just going to clear it up front. So let's say I create an entry. I create 2 entries actually. I want 2 entries. Right? So actually I don't want this, right? That's okay. No, I don't want this. That's okay. So we have 2 entries, demo entry 0, demo entry 1, and now I link them. So as you know, to do a link, you have to know the base entry hash and the target entry hash. And this is what I'm putting here. I'm just going to link them. This should link them. No, I made a mistake. Sorry. I should have maintained that opened. So creating 2 entries again. Copying the first hash to base. Oopa, there is an entry that didn't go forward. Okay. And now first entry, copy its hash, paste. Second entry, copy its hash, paste. And now we can create a link. So they are linked. Now what happens if I update demo entry 0? Let's find out. So first I have to go get the header that created the demo entry 0. So copy that, go to update entry, copy the header hash, new content. Let's see what happens. So if you can see, this is the first entry that we created, demo entry 0. Demo entry 0 has been updated with its create, but the link is still from demo entry 0, from the first entry that was created. That is, links don't go up the update chain. Links stay with the entry that they were first originally linked from, always. There is no way to automatically like make the links go forward. This is one of the things in which having a distributed system is really different than having a centralized system, because in a centralized system you can just modify the contents of the entry, right? And everything linked from and to the entry gets updated to the newest content, let's say. But in here you can't actually modify the contents of the entry. You can just mark it as deleted. So the links stay with the original entry, right? And that is really, really important. I don't want to cover more ground in this direction. Sid, do you think it's best for me to wait here or to go to the DevCamp application?
I think this is a really interesting topic. So we don't have any questions in Discord, but if there's people who want to unmute themselves and ask, does anyone want to jump in with just a quick question or reflection? Or
yeah, I have a question. I'm wondering if we can branch update chains into an update tree.
I was wondering if anyone was going to ask that. So the answer is yes. Okay, so basically the question is, what happens now if I, with this state of the affairs, what happens if I update again the create header, right? So let's just try it out. Let me reorganize a bit because it can get a bit messy. So the answer is yes, you can. If you see here, now this create header has 2 updates in it, right? And actually this update header could have more than 1 update in it as well, right? And you may say, wait, but what's the update that counts? And the answer is, well, it's up to the application developer to figure that out. Holochain doesn't have strong opinions on the way in which you will use update chains. It's more like, hey, I'm allowing you to update any header that you want. Well, not any header, sorry, only create headers or update headers. The way in which you use that for your particular use case is up to you. So you may say, okay, no, in my application, I can't allow for 2 updates for the same create. Okay, that's wonderful. If you want to do that, you just code validation rules to disallow that. And when you are doing the gets, like for example, in our application, we have things like get players from game code or get my own sessions, you would just filter them, right? Hey, I have 2 update headers here, but I only care about the first, the one that got there first by timestamp. For example, that could be a logic in your function, in your query read function, right? So yeah, like just for the sake of visualization and like imagination, what could happen, you could have a situation like this, right? So let's see. And I'm going to make this big, otherwise it's going to be. Right, so now we have first create has 2 updates, and then the second update has another update. This is a valid state for Holochain. Like Holochain just says, okay, create a new entry and add this piece of metadata to the old entry. That's totally doable and a good case for Holochain. Is it a good case for your application? Well, it depends on the application. There will be applications in which this is very wanted, like this mimics basically something like that like something like what Git does, in which this could be a piece of code, and then this is a branch, right? And then this is another branch, and it has 2 commits, right? This mimics Git, right? And you could implement Git really easily in Holochain. Or you could say, no, I'm going to care only about the a unique chain, because this is a chain of, I don't know, transactions. This is a chain of game rounds in which we are playing. For example, we are going to go through it. So this is the case with a lot of Holochain primitives, which is Holochain doesn't have strong opinions on the way that you use them. It's you, the developer, who has to apply semantics on top of it, right? So close round will mean updating the round entry in our case, but the internals about whether that's update or whatever should be contained inside our zone. And the only thing that's exposed to the outer UI layer are semantics, like close, try to close round, or create node and update node, right? So update entries and things like that stay inside the zone code, and the zone exposes only meaningful things to the UI.
Awesome. I think we're getting some more questions. How long is this section after this, Guillem?
I think I can be done in 5 minutes.
Even after like the demo, was it the demo? What were you trying to know?
Yeah. Like these are the one.
Oh, so then let's hang around here for a little while.
Okay.
Says reminds me of the Holochain blog, the next level collaboration apps with Sin, and I think that's exactly right. That's always what comes to mind when we talk about update trees. That link's been dropped in the Discord server. Kim, I wonder if just real quick you could share a little bit of, like, I'm sure you've had thoughts, or any of the other DevCamp members, like with regards to application building, like which kinds of applications would this be a good thing for, or what kind of use cases would this be good for, versus what kind of apps would this be a nightmare for, because then it would just lead to like a derailment with too much data being stored.
Right. Yes. So updates are a really nice primitive to have because they are bidirectional. Links are not bidirectional, for example. So if you create a link from an entry to an entry, it's only from the base to the target, not the other way around. With updates, you get more meaning out of it because the original entry gets notified about the update, and the update, like, obviously knows about the thing that's updating, right? So This using updates is useful in a whole range of scenarios. I'm going to talk about, for example, in content management, with any kind of user input, be it text, be it, I don't know, some numbers, be it whatever, updating and the update chains would normally work quite well. And with a very, very small sugar on top, you can implement things like branching and forking, which are very, very cool. And you, like, Holochain does automatic state like conflict resolution, in the sense that if you have 2 updates here, it's going to return like the list of updates, and then in your zone there is the function that determines which update to follow and so on. So what I'm trying to get across is that it's easy to code a zone that has, for example, forking of content, and it's very cheap in terms of Holochain storage and so on. Another thing that can be implemented with update chains, and actually I think update chains is the best way to go, is, for example, chain of custody. That's an interesting case. So in chain of custody, for those of you who don't know, it's basically, hey, I don't know, I have borrowed this book, right? I have a book, but I can lend it to other people, right? So if I can lend it to you, then we should both agree, right, that I lend it to you. So in Holochain, there is always a trace of who had the book across time, right? And there is a chain of custody, right? I'm the custodian now. Now you're the custodian. There is a chain of custody, right? That can be implemented with an update chain in which you have an entry that says this agent is holding this resource, and then you keep updating that. The thing is that imagine a fork in that update chain. That's not really what you want, right? So it's like, at least in this application logic, doesn't make much sense to say I received it from Sid and I lent it at the same time to Hedayat and Nastasia, right? It doesn't make much sense, because it's like, no, the update chain is just one chain. It can't be really forked, right? And if it's forked, then most likely some cheating happened. I tried to make it seem like I was giving it to Hedayat, but actually I was giving it to Nastasia. In that kind of scenario, you want to enforce one update, right? You don't want this tree forking tree. That's one case for a unique chain. Other cases for not using updates, right? So normally the decision is between using updates and using links, actually, because from an entry, both things are adding metadata to it. In the case of links, it's like, okay, this entry is related to these other entries. And in the case of update is, okay, this entry should be now substituted by this one, although it could have different meaning. So normally, if you have a one-to-many relationship, that's better implemented with links. If you have something that has to do with revision histories, has to do with, I don't know, latest, like you care about the latest state of something, that's better implemented as update chains normally. You can use that as a rule of thumb, but it's highly contextual. Like there are some use cases in which you could combine both and say, okay, we are going to use links for the players and we are going to use updates for the rounds, which is what we are doing in the DevCamp game, for example.
Awesome. Thank you. That was great. We have just one question, and I suggest we take that one question and then move quickly into the data round model.
Sure.
The round data model. Nectar's asking, how does this work with multiple DNAs?
Right. So actually, what I would say, okay, let me see if I should be able to do this. Let's see. So conductor admin, and let's see, admin API, clone DNA. This should work. Let's see, execute. Right, execute. Okay, yeah. So, let's put it here so that everyone can see. Okay, so what I did, I went to Rafaelia, right? And I cloned the DNA. So now Rafaelia has 2 DNAs installed, 2 cells, right? If I go to this other cell, then it's only Rafaelia playing this other DNA, right? So in this first DNA, you have 10 agents. In this second DNA, you have only 1 agent, right? So let's see. If I create an entry here and I update it, I don't care about animation. So let's see, let's say I create an entry here and I get the header, and I update it here, right? And then we have what we had at the before, more or less, a small update chain. Now I switch back DNAs. Notice in this DNA, there is absolutely nothing about what I just did. It's another DHT, which means that anything that happens in one DHT stays in that DHT. Like here, actually the only entry that is there is the agent entry that Rafaelia committed at the start. There is nothing else in this DHT. If in this other DHT, I create another entry, right? This is the demo entry 0 that contains this weird thing, and I go back to the first DNA, it's not going to be there. Like, right, this is the first 2 that were created. So you can think about DNAs and DHTs as completely separate hash spaces. They share nothing in common between them, a priori, right? Rafaelia is playing in both DNAs, so they could do a get in one and a publish in the other. But Fancy couldn't do that. Fancy is not playing the second one, right? I hope that answers the question.
Yep. Thank you. I think we move to the next section.
Cool. So let's now take this update chain primitive. I'm going to close this and apply it to our application, right? So we have the application for the DevCamp. We already went over these first functions, right? So you have create game code anchor, you have join gate with code, start game, like we all know this. So you create game code anchor. Okay, sorry. The new function that we are going to be showing today is try to close run, right? So let's create a game code anchor. I don't care about animations, so speed them up. Okay, perfect. Join game with code, and I'm going to join UPA. The code was ASDF, a nickname, whatever. Elin is joining. Also, Fifi wants to join. That's fine. Okay, so we had already seen that. Let's start a session for game code. We already seen that. Let's get the game round, the hash, and let's make a new move for Fifi with 2 and for Elin with 3. I'm going to take out entries that we don't care about here. And now we have, basically, this is what we had already seen, right? So you have a game session, which is linked to the first game round. And that's linked to all the moves that were made in this round, right? So a session has multiple rounds, a round has multiple moves, right? This makes sense. What should happen when we try to close the round, right? So we are going to use update entry to update the game round here, to be able to have the update chain be the chain of all the rounds that happen in this game. So I'm going to get the game round hash here. Notice this is the game round entry hash, but inside this try to close round, we are doing the logic of getting the header hash instead of the entry hash. So I'm just going to execute. Let's see what happens. So very convoluted, sorry about that. So we have game session here. Game round, like this, thanks. We have game round 1, actually is the first game round that was created. So this is the one that we just updated. And now we have a game round 0 that updates game round 1, right? And what we are going to do is moves for this new round are going to be linked from this new entry that was just created. And in this way, we have an entry for each round, and every round, its entry is linked to the corresponding moves, right? So you don't have all the moves linked from just one thing. You have separation of concerns, right? So each round takes care about the moves for that round. But you can also go from first round to get all the subsequent rounds, right? So you have discoverability, forward discoverability to go from one round to all the other ones. And you have, for each round, you have the option of getting all the moves that were linked to that round. So I'm just going to make a new move with the second round, right? I get the game round, new round hash, and I paste it here, execute. What just happened? Missing dependencies. That's okay. Oh, I may have a bug. That's interesting. Let's see. I do have a bug. It's interesting. Okay, sorry about that. I'm going to update it when we are done. You would see a new move created and linked from this game round, right? And you can imagine every new round, we are going to be updating this first one, second one, updating all the way down. And at every point in time with make move, we are going to just link from that new round. That's it for like the presentation. I don't know if there are questions here.
Thank you. We don't have questions in Discord. I would welcome people to just unmute themselves and ask. We have 5 minutes before the break.
We're running into the same thing as earlier, where the game round integers are kind of appearing in a random order. Yeah.
Exactly.
Yeah.
Yes.
Okay.
Yeah.
Okay.
So just to clarify, the game round 1 actually was the first one created. Game round 0 was actually the second one created.
All right. Thanks, Guillem. Thanks for the session. And we're going to move to Nastasia's session, where she reviews the code for closing the round.
All right, so this is the code that we've left since the previous session, with one small remark. The try to close round function is a very big one, actually. So we would first define all of the building blocks for this function, and then we would write the final function. So the first small thing that we're doing here, we are adding a new module called utils, where we would be having functions which simplify working with holochain and are not actually related to any other module. So we are introducing two new functions which are doing things that we've already been doing so far. but we would be doing the same operations multiple times, and it would save us some time and code reading space to have those functions separate. So the first one is to try and make a get into the DHT with an entry hash provided and get options. So there are two different ways of get options to be defined. And just to make this function configurable, we would be accepting this as a parameter. And I would focus on this a bit later. And then the second function is the one that converts an element from DHT that we have already retrieved into an entry of the type called T. And this thing here means that type called T has to implement a trait try from for an entry, meaning that any type for which we're calling the try from element function has to be able to convert into a whole chain entry. So here we are receiving an element, and as a reminder, not all elements have an entry, only create and update elements have. So an easier way to catch both of those would be to use this construction, which basically means that whatever the element which has an entry present, this is the case. So we are matching an element with an entry, and if we are successful, we are going here. So we are trying to convert, so this thing under selection is where we're converting a whole chain entry, which we got from the element, into a type called T. So you can notice some nice Rust thing here, which allows me to print the type name of T into the error message, making it easier to read. This is a part of standard library in Rust, and it's available outside of whole chain ecosystem as well. And then for any other element that we would get, we are just returning an error, because that means that this is not an element that we're looking for. So with those two functions at our disposal, let's go to the next commit and see what we can do next. So on the last session, we have started to make a move, but we didn't actually do anything after this. So players are only able to make their move, but that's it. So the next logical step after everybody made their moves is to retrieve those moves from the DHT. And this is the new function that my commit introduces, which does exactly this. So as an input, we're receiving an entry hash for the round for which those moves have been attached. And now with this data, we are retrieving links that would start at the last round hash and would have a link tag that is called game move link tag. As you can see in the function written previously, new move, we are creating those links here. So now we're just retrieving them. That's basically the same scheme as we did with the player profiles. So the code is very similar, with one small difference. Instead of writing the get from the DHT manually, we can now just write try, get, and convert. And we would be sending as an input parameter an entry hash for the link target, meaning the entry hash to which link points to. And we don't have to do any of the conversion ourselves. We just get a game move entry as a result, and we can add it into the vector. And as you can see from the signature of this function here, it returns a vector of game moves. So an important thing here to note is that this vector wouldn't be sorted, and the order of these moves would be could be different at any point in time. So like as many times as you do this get, you could get multiple different orderings of the same moves. This is because our game is not required to have a strict order of moves, because first we wait for everybody to make them, and only then we're calculating the state. This is opposed to the chess game, in which it's crucial to maintain the right order of moves. So here we are kind of having an easier situation, so we don't have to worry about sorting. So we are doing this retrieval, and we are able now to answer the question, so how many moves there are and which those moves are for a specific round identified by a hash. Now that we're able to do this, let's go to the next step. And that would be a bit more verbose. Sorry. No? Okay. Sorry, I am getting confused with my Git. Okay, so
Oops, I think we've lost Nasaja.
that was a convenient time to drop off, I must say.
That was a quick recovery, though.
Yeah,
I was
sorry about
thinking
that.
of a joke, but no, it's okay.
Yeah, you can still make it while I'm
No,
sharing the
it's
screen.
fine.
Okay. All right. Yeah, let me. Sorry about the delays. Okay. So the next function that we're doing is finalize moves. The name to finalize moves comes from the fact that at any moment in time, we could be trying to get the moves that have been made for a round, but it could be that there are not enough moves just yet. And also, it could be that there are too many moves, meaning that some agents may have cheated and created multiple moves for the same round, maybe trying to consume more resources or to do something else. So in order to clean those moves that we have and make sure that for any future calculations, we would only have a list of moves which only has a single move per player, we need to do some processing here. So as an input, this function would receive the vector of moves, which basically we retrieve from this function, and also a number of players, which we define in game session. So this is always a known parameter. And what do we do with this data? So we would verify that we have enough moves to proceed. So the first check that we're doing is, do we have more moves, less moves than there are players? If we do, it means that we cannot do anything further, and we need to wait for other players to make their moves. So we are returning none. Yeah, an important note about this function is that it returns a result inside which we have an option, inside of which we have a vector, which means that it either returns a vector or it doesn't return nothing, meaning none. So every time we return none, it means that we cannot proceed further, and it doesn't make any sense for us to return any moves. So the first step is to verify that there are not less moves than there are players. Okay, that's fine. Suppose we have verified this. Now we know that there are at least as many moves as there are players. Now we need to make sure that the opposite case isn't, now we need to handle the case there are with multiple moves per single agent. In order to do that, we are creating a B-tree map. As a reminder, we are not using hash map in holochain because hash map has an unordered set of keys, and that would disrupt entry hashing. And B-tree map guarantees the order of its data inside, so the hashing would be stable. So we are creating the B-tree map, and we are populating it with the moves that we received as an input. So for every move in this move, we are trying first to get a mutable reference to it. And then if this owner isn't registered in the B-tree map just yet, if owner isn't registered, this is the case. Then we are just inserting the owner pub key as a key, and then a vector with their move, which only has a single entry. But if this owner is already in the B-tree map, then we are just pushing the next move into the vector. So now that we have processed the moves here, we can be sure that at least we know how many players have made their moves. Because if we have 5 players and we have 5 moves, it could be that there is only 1 player who made 5 moves. After doing this processing here, we can be sure that if we have 5 moves, if we have 5 players as case, then each of them has made at least 1 move. We are checking if somebody is still missing, and if this is the case, we are once again returning none from this function. So now that we have made sure that we have all of the data that we need to clean the moves from everything that's unnecessary. Originally, we wanted to add a timestamp into the game move and sort the game moves by the timestamps and retrieve the one that's been made, that was the first to be made. But that was a bit optimistic. I mean, we didn't have time to implement this. So instead, we did a bit of a hacky way in which we are just taking the first element of the move vector, which is absolutely not guaranteed to be the first move to be actually made by a player. And for now, this is how we're doing it. There is a room for improvement, obviously, but that's just how we have it for now. So this is the branch where we're actually returning a non-empty value, which contains all unique moves for every single player in the game. With this function at our disposal, we can now query all the moves and make sure that we have a proper list with which we can make any further calculations. So after we have this, we would be calculating the round state. So we have everything for the game move for now. So we're moving to the game round module, and we would be writing this function first. So the calculate round state. If this function would receive the Rust struct instance of game round as an input and game parameters, and then a vector of player moves, which is already guaranteed to have unique moves. And this function has to be lightweight because we would be also using it in validation, and there are different rules for querying DHT in validation functions. So this function doesn't do any data retrievals and only calculates the state using the parameters it has been provided. So what do we want to do here? Essentially, we want to sum all of the resources consumed during the round, subtract, so first one. This is where we're summing all of the moves that have been made during the round by all the players. This, we are getting the total consumed resources in round. After which we are calculating how much resources we have left after all of this consumption happened. And after this, we are calculating the total leftover resource because, well, we also have a regeneration factor, which defines how our resources change between the rounds. And it's a floating point number, which is why I have to do this as F32, because the resources left is an integer, and this is a floating point, and Rust requires me to explicitly specify all type conversions. So in order to multiply int by floating point, I need to do this, and then back to int, because I want this value to be integer. And after that, we already know how much we have left. And just for the statistics and for being able to display data to users properly, we are also calculating how much resources did we grow during the round. This value could be negative depending on the regeneration factor value. After we have all of this, we are just transforming player stats from the player's moves. And that's another helper function which we define, which essentially converts a vector of game moves into a different data type, which we already defined with the game session, which looks like this. So here we have agent pub key as a key and resource amount as a value, but the original game move has different structure. So we need to do this conversion to display data in the user interface and also to be able to calculate further things during the round. So getting back to the game round, suppose we have processed this data and now we can create a round state, a new struct which defines basically the round state. So it only talks about the resources. And this is where it's useful for us to have round state separate from the round itself, because we can just return this struct and not worry about filling some additional fields. So with our ability to calculate the round state from the moves that we have made, the next comes ability to check if we need to start a new round, or rather if we can start a new round. So our game has a fixed amount of rounds, and also our game could be lost at any of those rounds. So we're writing a very simple function here, code can start new round. It accepts the game session as an input parameter, the previous round, and round state. Once again, we're only dealing with raw structures because we only need their data fields. We're not doing any DHT queries. We're making sure that the previous round +1 is less than number of rounds in the game, meaning that we wouldn't be creating more rounds than there are supposed to be in our game. And as a second condition, here with 2 ampersands, we're also making sure that our game is still not lost and there are still resources left to consume. Otherwise, it would automatically mean that the game isn't lost. So now that we're able to calculate this, we would create another helper function, which is called create new round here. And this is a function. So let me get back to the game session for a second. This is the code that we have shown you sometime previously. One second. This one. So as you can see, when we're creating round 0, we are just running the new method of the game round. This is because the round 0 is actually an abstraction for us to attach moves to, but it's an empty round. It has number 0 for the specifically. You can see that there is no data, almost no data, except for the session and the initial amount of resources. But now that we would be creating next rounds, we need to do something more than just creating this one and calling a create entry. So I'm going back to the game round module and reviewing this function. First thing we do is very familiar. So we are calling the game round new method. And we are feeding into this method data that we received from the round state. So we've already calculated this about the resources, and we can just populate it here. And also, for this new round, we are writing all of the stats of our players from the previous move. This is a bit of a tricky moment that produced a lot of discussions during our development within the organizers team, because it actually means that we are kind of working backwards. I mean that we are just creating the round number 1, but it already has stats of players, because when we're creating round number 1, we are kind of closing the first round. So this would make more sense once we get to validation, because it would be clear why do we need to store this statistics data exactly in the game round entry itself, while we can perfectly well query it from the DHT. So this data duplication is actually needed to make it easier for us to calculate and validate entry states later. So we're calling the game round new. And at this point, we have just created a Rust structure, and now we need to call an update entry. And this is the function which is creating an update chain that Guillem has talked about in the first part of our session. So you can notice that we're using the header hash here, because we receive it as an input parameter. And as an entry that we are updating would be our next round, which means that, hey, commit an update to this header hash and create a new entry with these contents. After we do this, we are once again calculating an entry hash after we update it. So this would be a hash of a new entry, which contains the next round in it. And once we do this, we just return the entry hash of an update entry to be able to identify it further. So now that we have all of the building blocks, I think, one second. Yes. Now that we have all of the main building blocks, we can go to the try to close round function. So first idea about this function is that this function is designed to be called by any player in the game at any moment in time when the game has already started. So there exists at least one round identified by the hash. This is made to compensate for the eventual consistency that we have, because, well, if everybody has made their move, every time an agent makes a move, they can check if they can close the round, meaning what if other players have made their moves at the same time, and now we have all of this data to close the round, and everybody can do this. Having this mechanism allows us to reduce the waiting time for players, because the first one who receives all of the moves during the data propagation can close the round, create a new entry. I mean, propagate this update chain, and then everybody else would receive the updates and be able to proceed. So the first thing that we're doing here in this function, as Guillem has already mentioned, is that we're converting the entry round hash into an element. And the thing is, since we're working with update chains, we would need both element and Rust structure for the game round, because we would be using both of them. So this is a function that we have already defined, which retrieves us an element from DHT, and we make sure that this is actually an element. And then once we have an element, using the try from element function, oh, I didn't walk you through this. This is another helper one, which is kind of similar to what we did already, but instead of doing a query into DHT ourselves, this function just receives an element and converts it into the entry. So this is a very similar code. Getting back to this, we now have last round element and Rust structure. Now we are doing the same thing for the game session, because once again, we would need both things. And now once we have those both two, we can retrieve moves for the round. And there is also room for optimization here, because you see, once we retrieve the last round element and we get the Rust struct, we would know what is the number of the next round after this one that we're trying to close. So we could try to do a query into the DHT, calculating this new round, and save ourselves one commit. I mean, that would be a small optimization, but just a food for your thought. So now we have moves, game session, game round. Now we're calling our function Finalize Moves to make sure that we have enough data to proceed. And there are two branches of this match. The first branch is the case where we do have enough data to proceed. And since Finalize Moves is returning us unique moves, this is how we call this variable. So inside of this branch, we are defining a temporary data structure, which we only need to be able to show data to the users. Because in the game moves, we would only have the game of data and then the agent pub key. But here we would have an amount that has been consumed during the move, a string value which we could populate later with an actual name of a player. We didn't do that. And then this player's pub key. So that's just a convenience for the UI to be able to get this data from backend and instantly show it to the user. So once we populate this with our moves info, we can now proceed to calculate the round state, meaning that we would know how many resources have been consumed. We are using the function we just defined. Now that we have the state, we know about the resource situation, and using this knowledge, we can check if we can start the new round. We are passing here the game session because game session contains data about how many rounds there are in total. And we're passing the last round to get the resource consumption from it, as well as round state. Sorry, we are getting round number from the last round. So if we are able to create a new round, we are doing exactly that. So we are calling this function to create a new round. Once we do this, we are returning an answer to the user interface with this new structure called game round info. So this data structure, let me go up, it's a bit redundant because it kind of repeats things that we're defining inside of the game round entry. And the main purpose of this structure is to be a universal package for the data for multiple cases. So either we are waiting, or we can close the round, or we have finished the game already because this round has been the last one. This data structure allows us to package all of this data in the same form. Probably you could refactor it in a different format, but this is the one that's working for us right now. So let me scroll back to where I was before. So we're returning the game round info, which the most important part here is that the next action would be the start next round. This is a field that our user interface is using to determine what to show to user next. We would post the user interface code later for you to read, and you would see how this is implemented inside of the Svelte framework. So that's the case where we do have enough data to create a new round. But no, that's the case when we can start the new round. And if we cannot start the new round, we're returning the game round info, which, as you can see here, we're packing data into sum because there is data to show. But if the game has ended, for now, since we didn't implement the code for ending the game, we are just adding here placeholders, none for everything that we can. And we say to the user interface that the next action is show game results. This part of the code would be refactored later, but for now it's just a placeholder you don't have to think about too much. So this was all for the branch in which we're able to receive the unique moves from the Finalize Moves. But what if we receive none? This means that we still cannot close the round because not all players have made their moves, in which case the user interface only has a single option, which is waiting. User interface can try to call the same function later with maybe a different result, and maybe some other agent would be able to call this function for themselves and close this round. And the thing is, with Holochain, if multiple players call the try to close round function at the same time and think that they are the one who is closing the round, then as we explained previously, we would just have two different headers for the same entry contents, and the game data model would be intact still. So I think that's it for the game round for today. I hope this wasn't too chaotic.
Thank you,
Or a night.
Nastasia. Thank you, Guillem, or a night, or an afternoon, or morning, whatever you might be. Thank you for hosting these sessions.